In this video, we're going to discuss expanding and compressing logarithmic expressions. To do so, we just need to discuss three log properties that will be very useful, and then we'll demonstrate how those properties can be used in both the expanding direction and the compressing. So it'll make a little bit more sense as we dive in here. Let's begin with something called the product property. So what this property tells us is if we have a log of base b of a quantity x times y, so there's a product involved, hence the name, then we are able to break this up or separate it as two logarithms that are being added instead. So this would be the equivalent expression here on the right-hand side. And again, this property works from left to right or from right to left. So as we start getting into some examples, if we begin with something like the left-hand side, and we're moving it into multiple logs, we'll call that direction expanding because we're making it bigger. If we start with something like what we see here on the right, and we're moving towards something like what we see on the left, we'll call that compressing or condensing because we're making it smaller. So this property actually can make some sense if we relate it to rules we already know about exponents. So I'm just going to throw this out here for what it's worth. Remember, if we have something like x squared times x cubed, right? That tells us that we would add the powers. I relate this product property to that principle that we already know from exponents. So in case it helps, that's just a little comparison, and I'll do that with the other properties as well. But again, our focus here is on using them to rewrite logarithmic expressions. The next property we'll look at, these aren't in any particular order, but will be our quotient property. So quotient is a division word, so as you would expect, this tells us that if we have log base b of something like x divided by y, then this can be rewritten as, and what would you think? If multiplication changed to addition when you expanded, what will division change to? So these two quantities will be separated out, and the operation between them will become subtraction. So again, for what it's worth, I'm just going to draw a quick little analogy to our rules of exponents that we know so well. And that is, if I'm dividing, like let's say x to the fifth divided by x squared, right? To simplify that, the rules of exponents tell us to subtract. So dividing ends up subtracting the exponents. So again, if that little comparison helps you like it helps me, then that's kind of cool. The last property I'll mention, this is the third one, will be the power property. And it would be good to have these three properties written down so that we can then apply them to some examples together. So the power property would state that if I have log base b of x, I'll say x to the power of r, right? So you get a little exponent on the argument there. Then what this property allows us to do is pull the exponent down out front. So it would become r times log base b of x. And my little analogy for that one is, remember in the past how when we had a power raised to a power, right? That would be the same as multiplying the two powers. So I'm able to multiply by the exponent. So again, that might just be for me, but I'm sharing it because it's always the comparison that I build in my head. It's so nice to build on prior knowledge that we have. Okay, so make sure you have these written down. I'll kind of show them a little bit more thoroughly here before I move to the next page. And then let's just try a couple examples of using these properties. So you've got your product property, which shows us that a single log expression can be expanded to adding the log expressions if multiplication is the operation between the terms. We have this quotient property that allows us to expand division into two logs being subtracted. And then our last property here was the power property, which allowed us to bring the exponent down out front as a multiple. So if you have those written down, then you're ready to go on. Otherwise, feel free to pause for a second. I can't really show them quite all on the same screen, so I'll just slide back and forth for a moment here and make y'all seasick. Okay, that was probably good enough. All right, so let's just try a couple examples. Let's start off with a single logarithmic expression. So if that's the case, then the directions would say something like expand, because we would want to pull it apart. So let's say we have expand log base 5 of x to the 6th y squared divided by z cubed. So I'm giving us a log expression that has a lot going on. This is going to require us to use all three of the properties we just discussed. It sounds like a lot, but we can take it kind of step by step, and before too long you'll be using these properties without any trouble. So I'd like to start by just rewriting what we were given by using some intentional colors here. As you guys know, I'm pretty fond of color coding things. So I'm just going to highlight the exponents that I'm seeing. I'm going to make that multiplication between the terms a little bit more obvious. And I'm going to highlight the division that I see. So this is just my personal step of preparing for the properties I'm about to use. So I can see that I'm going to be using the product property because I've got multiplication, right? So the product property will get used. I can tell that the quotient property is going to be useful because I've got some division going on. And I'm going to use that power property, looks like 3 times because I've got 1, 2, 3 different exponents. So you can do this all at once or in a couple steps. Given that it's our first example together, I'm going to take some steps. So for my first line, what I'm going to do is break out the multiplication and division as addition and subtraction. So here's my multiplication changing to addition, and that means I'm adding the other term in the numerator, which was the x squared. So far I've broken up the two numerator terms that were being multiplied, and I've written them as 2 logs being added. Here's the division becoming subtraction of the denominator term, which was log base 5 of z cubed. So far we have changed multiplication to addition of 2 logs. We changed division to subtraction. Good, so if that seems all right so far, then my last step will be to pull these powers down out front. And then that will be a fully expanded logarithmic expression. Here we go. So let's say 6 log base 5 of x plus 2 log base 5 of, I think you guys noticed that, I'm sure. My x back up here was supposed to be a y, so I do apologize for that. Just a copy down error. So in case I just caused some disruption here, sorry about that. At the beginning I had a y squared right here, and then I somehow magically changed it to an x, so I just caught that. You all probably saw it sooner, but I couldn't hear you. And then the last term would be 3 log base 5 of z. So that would be our fully expanded logarithmic expression. So that's about as crazy as it gets in terms of expanding. Some things that I'll just bring out real quick to watch out for. If you have radical terms, don't forget that that can be rewritten as a power of 1/2. So I'll maybe do an example that uses that idea. So sometimes people forget that radicals still can be written with exponents, right? So although we don't write the 1 on the x or the 2 on the index, they're understood. So if I gave you like a cube root of x, the power of x, the power on x, again, is understood to be 1. So the cube root of x would be the same as x to the 1/3. So that's one thing that comes to mind thinking about expanding that I've heard can catch people off guard, is just how do we deal with the radical? So if you have a radical involved, you could use the power of 1/2 if it's a square root, 1/3 if it's a cube root, and so forth. So I'll just end with one example involving a radical, and then we'll see if we can move the other direction. Because it turns out the other direction is actually more useful in terms of solving. For this one, let's say I was given the natural log. I'm going to use a natural log because we haven't lately, of the square root of x times 5. And let's divide that by y times z to the 4th. So I'll make a little bit more going on in this one. All right, so that's my original logarithmic expression. Our job is to pull this guy apart. So I'm going to start the same way I did the last example, which was, let me just take a moment and kind of get some color coding going. I am going to rewrite that square root of x as x to the 1/2, as I mentioned, so that I see it as an exponent. I'm going to highlight that multiplication between the x to the 1/2 and the 5. Let's emphasize that division. Let's make sure we're good in the denominator, that we're multiplying y and z to the 4th and highlighting that power of z. So this step again is not necessary. I just think in terms of running through it with you guys for a first time, sometimes color coding can help correspond to the properties. I wonder how many of you take notes in colors. That would be kind of a fun thing to find out. So now I'll go ahead and use the product and quotient properties. So I'll start by saying my numerator, which was ln of x to the 1/2 times 5, would become ln of x to the 1/2 added with ln of 5. And then the denominator means I need to subtract. Now I have to be a little careful because I'm subtracting two logarithmic expressions. They're both in the denominator, so I'm going to protect that negative by using parentheses so that the two terms I'm about to place inside the parentheses are both subtracted. Be a little careful with that because the fact that y and z are both in the denominator means I just need to make sure I'm subtracting both of them. So one easy way to do that is to use parentheses. I'll talk about one other option before we wrap up this example. Okay, so we have an ln of y that came from the denominator, and then I'm going to add that with the other term in the denominator because in the denominator those two terms were being multiplied. So we've got an ln of z to the power of 4. Okay, hopefully that's looking pretty good to you all. So I think we've implemented the product property, both top and bottom, and then the quotient property, separating the numerator terms from the denominator terms. So a good wrap-up point for this one would be to just drop down those powers. So I'd get 1/2 ln of x plus ln of 5 minus ln of y plus 4 ln of z. And as promised, let me just talk about one possible alternate solution. I think you guys probably see it also. If you preferred to distribute that subtraction, I could say minus ln y minus 4 ln z. And that way, again, all we're doing is we're distributing that negative to say both of those terms should be negative logs because both the y and the z terms were in the denominator. So either one of those last answers would be totally appropriate in terms of expanding the log, so take your pick for either of these last two. Cool, so hopefully that feels pretty good on expanding. Again, expanding is when given a single log expression, pull it apart. So I'm going to wrap this video up by just looking at the other direction, which is, you can call it compressing or condensing. Those are both words you'll hear about this last set of directions. And that would apply to a situation where we've got multiple logarithms. So let's say I've got 3 log base 5 of a, and that's being subtracted by 4 log base 5 of b, subtracted by 7 log base 5 of c. So now we begin with many, and we're trying to push it back. So I'm just using the same strategy we did for those last two examples in reverse. So I'm going to begin by color coding. So I'm not doing anything in this first step. I'm just color coding to remind myself what properties are going to be useful. So I see my power property. I see a subtraction sign, so that tells me I've got some quotient property action. And I see another subtraction, so that tells me I've got two things hanging out in the denominator. Okay, I think that should be good. Sorry, I'm doing weird things today. It's the end of the day. I magically changed that 4 into a 3, so I'm fixing it sooner this time. So again, sorry about that. Ooh. All right, so all I did was color code. Does it look okay now? I think so. And let's go ahead and use again, the reverse strategy. So let's begin by kicking the exponents up, if applicable. And it is applicable. All my terms have exponents. So an initial rewrite could be log base 5 of a cubed. We'll still emphasize minus log base 5 of b to the 4th. And we'll emphasize that last subtraction sign. And then log base 5 of c to the 7th. So I may have slightly glossed over the fact that it does really matter that all the bases here are the same. So those properties only apply if the bases match. So just a quick check here so that we don't neglect it. All these log terms on the screen are log base 5, so we can compress them using the log properties because they share the same base. So in order to compress these, I'm going to have a single log base 5, and then I'll just put a big parentheses to float in all the terms here. The first log was positive, so a cubed goes in the numerator. Then I'm going to divide by not only b to the 4th, but also c to the 7th. So sometimes that little step can be a little weird. Notice both the b log and the c log were being subtracted. If you'd like, we could have said pull the negative out front and understand the operation between them to be addition. That's another way to view subtracting both of those terms. So at the end of the day, we end up with a single log, right? The goal was to compress or to condense, and that's exactly what we did. So let's leave our answer right here as the single log expression. So I hope those properties are making a little bit of sense. I know you want to know why we need them, so check out the next video for some solving.